The original question was, have you ever wondered where trigonometric ratios come from and what do they mean? Let's put together what we have learned about similar triangles with what we know about right triangles. By substituting the BC over AC with opposite over hypotenuse for the blue triangle and substituting B prime C prime over AC prime of the orange triangle with opposite over hypotenuse, we arrive at this ratio. Again, we know these ratios are equal because the right triangles are similar. But what does this have to do with sine, you ask? To see where sine fits in, let's consider the measures of these 30-degree triangles. First, we'll start by measuring the leg opposite angle A, which is 4, and then measure the leg opposite angle A in the orange triangle, which is 3. Reviewing the similar right triangle ratio we created earlier, we still have more measuring to do. Let's measure the hypotenuse of the blue triangle, which we find to be 8, and the hypotenuse of the orange triangle, which is 6. Now we want to replace those numbers, opposite leg with 4 and hypotenuse with 8 of the blue triangle, and replace opposite in the orange triangle with 3 and hypotenuse with 6. The next thing we want to do is reduce those fractions. We see that they equal 1/2. So when the reference angle is 30 degrees, the ratio of the leg opposite to the reference angle and the hypotenuse is 1/2, or 0.5. No matter what the actual sides are, the ratio of the opposite leg to the hypotenuse is always the same when the reference angle is 30 degrees. That's a lot to write, you say. You are so right. That is why the Greek mathematicians, who thought so too, defined sine to be the ratio of the opposite leg over the hypotenuse. So we write the sine of 30 degrees is 1/2, or 0.5. The sine of a specific angle is a constant. What if the angle is different, you ask? Good question. Because every right triangle with an acute angle of 20 degrees is similar, we know the ratio is always the same, a constant. The value of the ratio changes when the angle changes, but it is always the same ratio of opposite leg to hypotenuse.